All right, welcome everybody to the next episode of Key Points. Today we have Melanie Springer. So today we're going to be talking even more about diagnostic tests, specifically why it's important to prioritize the assay, working with assay teams, the scientists that are making these diagnostic tests. Talk a little bit more about prioritizing the assay when you're developing these very complex systems. Sample in, result out, high throughput central lab, point of care, decentralized locations, and kind of everything in between. At the end of the day, it really is the assay. Before we get into it too far, I am thankful today, this Thanksgiving week, that Melanie's on the show. Melanie, why don't you tell everybody a little bit about yourself, your background here at KeyTech?
Sure. As you already introduced me, my name's Melanie Springer, and I'm a mechanical engineer here at KeyTech. I started in 2013 and have been here ever since. Recently became a partner at the company, and I've done a lot of work in IVD and with fluidics in general. I would kind of consider microfluidics and cartridge designs one of my specialties.
Thanks, Melanie. So let's talk a little bit more about the assay. Why is it important to prioritize that, when you start looking at the diagnostic test from a cartridge and instrument perspective?
Well, ultimately, as you kind of alluded to, the assay is really what's getting the work done in the product. Ultimately, if your assay isn't going to work, you're not going to get the result that you need, or worse, you're going to get an incorrect result. So it's really important to abide by whatever rules, whatever chemistry rules exist in order to make that assay function. Obviously, we're designing like holistic products here, so there is going to be a cartridge, there may be an instrument, but ultimately, any decisions we're making related to the cartridge or the instrument are going to be driven by us needing to develop a product that correctly goes through the assay.
So certainly everyone can believe that you want to prioritize this assay, right? But when you get down into it, putting it on plastic, looking at it in an automated fashion, you could argue that by prioritizing the assay, you do save time and ultimately money. Why is that?
Yeah. Yeah, I guess, a lot of times in development, we're concerned with time to market and, decreasing development time and basically, thinking about the assay first is a mindset that helps to expedite that process by eliminating unnecessary challenges. We've worked with clients before that, maybe had gotten a few steps down a development process and had made some assay changes. And it's really important to remember that the assay is what's driving here, or else you might end up in a situation where you're honoring some legacy architecture for your cartridge or for your instrument or both that really isn't best suited anymore to the new or the current assay. So it's basically just a means of keeping you focused.
As you were talking, I think it brought up a good slight segue, a little bit off script here, but I'm going to go ahead off the script early anyways. So, it's prioritizing the assay as we've talked about, but for an assay or for a platform rather to have value, it's not being the ability to run one assay. It's the ability to run a whole menu of assays, some of which aren't even determined,
Mhm.
when you're developing the system. So how do you think about, developing a platform so that you can kind of adjust for basically future proofing either, customer decisions or assay roadmap? Because I feel like this is a really important consideration when we're developing these systems is develop it so that, yes, it's specific enough to run exactly what they're looking for, but also generic, if you will, as a platform to be able to run future assays. How do you keep that in mind?
Yeah, yeah, no, that's a really good point. And platform flexibility is something that comes up all the time. Yeah, so I guess to a certain extent, you do have to have a sense, of what the range of assays that you're going to try to achieve with this instrument is. And you have to have some sense of, what is likely to change from one assay to the next for this platform, within that menu of different assays that might end up on this instrument. It's really important to align on what's expected to change and what's not expected to change early in the project, and as much as it's possible to fold that into requirements, and so that you can make sure that you're able to accommodate differences as assays change from, menu item to menu item in terms of what different diagnostic tests you might be looking to achieve. I guess some examples of that are perhaps it's that that some of these assays might require a larger number of lyophilized reagents or a larger volume of liquid reagents, and that's something that you need to make sure that you are not, designing a cartridge that is just barely big enough to get by on the current assay. Or, maybe it's that temperatures might need to be, slightly higher or slightly lower for different versions of these assays. And kind of understanding and planning for and your instrument design, making accommodations to allow you to hit those targets that you might not know right now, but ultimately you may need to accommodate in the future.
I guess another corollary question to that original one about a platform or developing it for a future, roadmap. How do you design for different sample types? Let's say one is a nasal swab into a dilution buffer, right? But you also need to design something for blood in the future. Like, have you done that? And how do you sort of handle two different sample input types, designing
Yeah.
it as a platform?
Yeah, and I think that there's definitely parts of that we've done here, and parts of it that are more owned typically by our clients. I guess like if we're talking about swabs, they're going to need to figure out the chemistry that's needed to elute off of that. But we also know that there's likely to be need for some sort of agitation and stirring. So that's, the part of it that we would be more involved with, like less on the chemistry side, more on the, mechanical implementation. But I guess in a lot of those cases, you can, reuse parts of the instrument that can be utilized in either of those cases. For instance, with blood sample prep, a lot of times we might do mechanical lysis, and that is something that, that requires a motor, and maybe that's the same motor that you can use for, a stirring function that might be necessary for eluting off of a swab. I think that the important part in development is just to make sure that you are planning for any of those different inputs. So you should hopefully at least be able to define, what your intended sample types are from the start. And, of course, like things always change, but we're just talking about on trying to do as much upfront to minimize the schedule hit if those decisions do get made down the road.
Where is the core value in these assays for diagnostic companies? I feel like there's, magnetic beads, there's lyophilized reagents, there's pipetting in a lot of these systems. And of course, there's the measurement. In your experience, what have you seen is the most valuable, for clients? And where do you then focus most of your time developing the system that will automate these assays? Is it on the reagent handling? Is it on the detection measurement side, or is it a little bit of both? Yeah,
So yeah, I guess you're asking where the magic is, basically.
that's a good
Yeah.
way to put it. Yes.
A lot of times, it can be, in the assay itself, like we're saying that's like where you want to put your priority. A lot of clients that we have, come to us with like a really specialized way of being able to get some results. So some of the special sauce ends up, just in the assay itself. But other times, it's we do more novel things on the cartridge and instrument side in order to make drive things smaller or faster or more accurately. So it's definitely a little bit of everything, and it definitely is a different on a project by project basis. But I guess I would just want to make the point that even if no IP is coming out of your instrument or your cartridge in that design, that doesn't make it any less valuable or marketable of a product. There are plenty of assays, that, are doing something novel and can make like a big difference in the world. And it's just a matter of doing the diligent, detail oriented work of, doing a good cartridge and instrument design. That doesn't necessarily mean that you need to do something strictly novel in order to, turn that into a full-fledged product.
Gotcha. Yeah, you've mentioned a few times cartridge, as I have. So let's focus on that a little bit. Assay is king, cartridge is queen. I guess we're making T-shirts. All right, all right. So you've developed a few cartridges over the years, or worked on them. So when you see the assay and you sit down, okay, it's going to be automated on a cartridge, it's going to be going into an instrument. What are your top considerations when you sit down to effectively architect a cartridge assuming it's a cartridge going into an instrument, tell me a little bit about some of your considerations there.
Yeah, I think the first and most obvious one is just reviewing the assay and trying to figure out what aspects of that assay does the cartridge need to be able to support. So, for instance, aliquoting out specific amounts of fluid, doing fluid mixing, heating, magnets, ultrasound, optical. There's all these different ways of interacting your fluid and your chemistry. So first, I think coming up with kind of like a holistic list of all of those different, aspects of your assay. I think that in addition to that, I tend to put a larger emphasis on thinking about the volumetric accuracy requirements of the assay because there's definitely, depending on how tight your tolerances need to be there in terms of your fluid volumes, it could really drive you in a specific architectural direction. So, if you're trying to pipette or, move fluid at plus or minus 0.5%. That's going to put you in a region where you're talking about, pipetting or using a syringe driver. Whereas if you're, closer to the 10 to 20%, you might be able to, meter out into a chamber on your cartridge and use optical sensing. So that's definitely one that I think is pretty impactful in terms of how it drives cartridge design and generally the system architecture. Another one I think is reagent storage. There's oftentimes, assays that will need a lyophilized reagent for something because that's how you make that reagent stable. But a fluidic or a reagent that's a fluid um, for something else for a different reason, chemistry wise, based on stability. So it gets challenging when you have both of those together because you have to keep your lyos dry for the whole shelf life of that cartridge, and it can be challenging when you're storing it potentially together with liquid reagents. So that's also another one that's very critical to think about early. Because we've definitely learned that lesson and experienced lyophilized feed decay in cases where that's not, respected.
Those are all great considerations for sure, focused on the assay. And we're about halfway through the podcast. So at about the halfway point, this is when we start talking about the user. Now, I know it's about the assay, but let's talk about the user while we're halfway through here. When you're looking at automating the assay on the cartridge, talk to me about how you think about the user, though.
Mhm. So I think user workflow is a big part of cartridge design and architecture definition. I guess the installation of cartridges is user action and is something that a user is going to have to do regularly when interacting with a device. So making sure that that's intuitive and usable, is really important. So yeah, there's definitely a lot of different ways that can drive the architecture, and it's pretty dependent on an assay by assay and product by product, situation.
I think my favorite case study here at KeyTech, I'm sure you can agree in terms of simplicity and easy to use, is the UltraCrit. That cartridge is very simple. I mean, it's a ClearWave platform. You prick your finger, you wick blood right in. You're loading the sample directly into the cartridge that actually is going to be used to get your measurement. So I mean, that's like the holy grail, is sample into the cartridge direct from the patient that goes direct into the instrument. So one other comment I think you made about a planarity, and I think that's more broadly defined, I guess, as I see it, like design for test, design for visibility, having the ability to actually watch your assay run.
Mhm.
How do you think about design for test, when you're looking at cartridges or in the early stages of development?
Another, I guess, to start off on a kind of a related tangent, manufacturing is a huge part of this entire exercise. Where cartridge design is something that cartridge manufacturing is something that have to get perfect because you're making hundreds, if not thousands, or maybe even millions of these disposables in order to support your product. So ultimately, you need with a really good manufacturing plan and talk to your manufacturing partner very early, to make sure that you're setting yourself up for success. But even oftentimes we end up, with a short term and a long term manufacturing plan to the point that you just made and being able to have high visibility into your assay during development. So a lot of times, I guess there's no substitute for your eyes. If you have a cartridge and it's in embedded deep into your instrument in a place that you can't see it and you have an intermittent problem, you likely aren't going to be able it's going to be very difficult for you to debug what's going on without having, eyes on the system. So that can impact cartridge design in your short-term development phase to make sure that you're preferably using something clear. And then also oftentimes we end up designing fixtures that are much more open than the final design in order to support, development work as, fine tuning different like open loop commands or whatever as part of the assay.
Gotcha. So, yeah, having it be two-dimensional and see with your eyes is one way to do it. I guess talk to me a little bit more about, not to me, to our viewers, I suppose, uh, about some of the ways that we actually do or could do sort of in-process assay checks, right?
Yeah.
So optics, pressure sensing. How are you doing it on projects these days?
Yeah, I think optics and pressure sensing are definitely like the most valuable. We've used lots of IR sensors, both reflective and through, in order to detect fluid presence. So we have a lot of experience in that, and it's definitely a super valuable way of confirming that things are going as designed as intended. And then pressure is also a very valuable one as well. And so you can see whether you're getting cartridge leaks or if filters are wetting out, things like that. So I think those are probably the best two if you're not going to be able to look at the whole cartridge visually.
So that's a good segue actually into serving our customers, right? Our customers are the assay scientists, and we are providing them these test beds effectively. Sometimes it's a piecemeal portion of a cartridge, other times it's the fully integrated cartridge, but either way, we're providing them this data throughout the assay to help them develop and de-risk their assay. So can you describe how Keytech optimally works with assay teams so that the assay stays king and the program is preserved as best as possible?
In an ideal world, we get direct FaceTime with the assay team regularly. And what regularly means might be different on a different project, but it's really important for the engineering team to understand the challenges that the assay team has, and vice versa, and so that we understand where does the risk lie, and that both helps us to solve and focus on the correct technical challenges, but also kind of helps to steer project direction. I guess one reason that we often do fixture work in order to support the assay team, usually these fixtures are being used by the assay team themselves in order to facilitate, faster testing or just more representative testing of what the product will ultimately do. But one reason that we often do that is to support guard banding testing so that the chemistry team can help and hone in on the tolerances that are required on different aspects of the assay. So for instance, maybe you have a requirement for your temperature of your fluid to get to 95, but you might not know if that's okay if it's 94 or if it's 94 and a half or 94 and three quarters. Basically, we design fixtures to kind of allow the chemistry team to play with different variables, whether it's temperature, whether it's volume, and kind of see what does and does not break the assay. That's one reason I guess that we do fixturing.
Got it. So describe a little bit more what you think the optimal sort of handoff points throughout a development program are.
Yeah, it definitely depends program to program. I think that there are times, when based off of engineering challenges that may be driven by, marketing rather than assay. There are times that engineering can provide feedback to the assay, and they can kind of go a different direction. That doesn't always work, but like I have had experiences, where that's the case, where, we could use a different type of chemistry to account for the fact that this instrument's going to be super expensive because the tolerances on the heater, like I was just as an example to reiterate, if those tolerances are really, really high, maybe it means that we need more expensive electronics or, it's just a more complicated, larger instrument. So then we kind of have to push back on assay and say like, hey, how's a different way that we can do this? What parameters can we adjust to still be able to get the correct results, but also meet these other requirements. So
Gotcha.
yeah.
So yeah, sounds like it's very much a dialogue, and that's probably the key word here. When you're looking at automating assays and prioritizing the assay, it's yes, the assay team ultimately is making some of the key, will the measurement work or not? But there are other sort of strategic go-to-market, if you will, strategies or packaging, as you say, that will push back. So we're pushing back on cartridge cost, right? Because that's the razor blade, pushing back on instrument cost, and what are the different ways to, heat, cool, push fluids, all those sorts of key subsystems to drive the assay on the cartridge. So it's very much a dialogue. I totally agree. We show a process diagram, right, that shows, de-risk, identify the variables of interest by conducting a sensitivity analysis, a Bible, if you will, of all the steps of the assay. And then you develop the test fixtures to study those variables of interest. And then you learn, and then you architect the system. But in the show prep, you mentioned that it's kind of funny to try and conduct a sensitivity analysis initially. And you mentioned there were some challenges with that. What do you mean by that?
Yeah, I think it's difficult because, like, in an ideal world, we would be able to come up with a really robust requirements set driven by assay that was defined, even before we're really, starting to dive deep in architecture development or just design in general. But functionally, there's a lot of times when when the design of the cartridge and the instrument can kind of fold back and shift those requirements or cause us to take a second look at the way that they were, early guard banding studies might have been run. And sometimes those just need to be repeated in a more realistic sense. So I guess for an example, to give it some context, you might have a portion of the assay that's been typically run on a off-the-shelf PCR thermocycler in a 96 well plate or something like that. And in your actual cartridge, maybe your volumes are different, and for sure your aspect ratio is almost certainly going to be different. So maybe as opposed to that fluid being in a well, maybe it's in a channel or, a thin chamber or something like that. And the thermal uniformity, for instance, might be different in either of those scenarios. And it'll call into question, the original temperature requirements that were set based off of this early benchtop testing might not be applicable in this new situation. So requirements are always tricky. We're always, questioning what's important, what's not important. But it is definitely something that needs to be revisited throughout the course of the project and is a key part of why, a communication between the assay team and the design team is so important.
Awesome. Yeah, no, that's a great example. I hadn't even thought about that with the temperature uniformity changing. I imagine the similar sort of arguments apply for the other variables of interest, right? Like volume control, of course, temperature control, rehydration of lyophilized reagents,
Yeah.
mag beads too,
hmm
and other sort of lysing methods, right?
Yeah, definitely. Yeah, I could probably go down a spiel on anyone that is. I'll spare.
Go, yeah, yeah. Yeah, that's the bait, I guess. Well, great. Yeah. So, I mean, I think it's great you've outlined some of the key challenges and with automating an assay on a system and why it's important to have that continued dialogue, between a development team and your assay team working together at various key touch points early on, getting those test beds out to really understand what the variables of interest are after your sort of cursor evaluation on basically on a spreadsheet, or as you mentioned, a simple, 96 well plate sort of platform. So with that, Melanie, I guess, do you have any other high level learnings from being in the trenches these last couple of years?
I'm not sure. I guess patience and due diligence. I feel like that's really all the product development's about as a whole. So, yep, stick
Awesome.
with it, I suppose.
Great. Well, we'll definitely be doing that. We'll definitely be sticking with it. So, hey, thanks for your insights, Melanie. Appreciate it. And thanks, everybody. Don't forget to smash the like button there on YouTube and listen to more podcasts here in the future. We've got a big plan for 2022. Lots of new guests and topics to cover. So stay tuned, everybody. Thanks.